All right, hey everyone, my name is Joseph Jimenez. I'm working on chapter 9 and I'm doing problem 45. And the question is, what is the angular momentum of the moon around the Earth? The moon's mass is, I have it written down right here, 7.4 times 10 to the 22nd kilograms, with the Earth's radius being 3.8 times 10 to the 8th meters. And the period is 2.36 times 10 to the 6th seconds. So those are our givens, and we also need to look at just to know that, what's it called? That our angular momentum is equal to inertia times our angular speed. And to also know that our inertia is equal to the mass times our radius squared. And so we're going to use those equations, and the first thing we're going to do is recognize that angular speed is equal to 2 pi over the period. And because they already gave us the period, we just plug it in, and so we get 2 pi radians over the period of 2.36 times 10 to the 6 seconds, which is then going to give us a angular speed of 2.7 times 10 to the negative 6th radians per second. So from there, we need to calculate the moment of inertia of the moon about the Earth. And since the Earth-Moon distance is much larger than the radius of the moon, we can model the moon as a point of mass, which is kind of confusing, but after spending a lot of time on Google trying to figure out this problem, that's what I got. And so I'm going to write up another equation, and I'm going to pause it so you don't have to see that, and then we'll finish solving the problem. Alright guys, so now that we solved for that, for our angular speed, we're going to solve for our inertia. And since we already were given our mass and our radius, we'll just plug in our mass and then our radius and then square the radius, which is going to give us 1.1 times 10 to the 40th kilograms times meters squared. And then we're going to go back to our angular momentum problem, where it was angular momentum is equal to our angular speed times our inertia. So we're going to plug in our inertia and then our angular speed and multiply by each other, which is going to give us an angular momentum of 2.9 times 10 to the 34th kilograms times meters squared per second. So it's obviously going pretty quick. And that's it. Honestly, what we were given with the problem, all we had to do is put in the correct formulas and then plug and chug and solve for our variable. So thanks for watching.